Hey everybody, just a short video today on classifying solids. This one's really vocab heavy, so there's not a whole ton of math we're going to do here, calculating wise. We're just kind of focusing on understanding the words and the vocab. So the first thing we want to talk about is something called a polyhedron. That's any solid figure that has flat faces that are polygons, so like shapes with like straight sides. So that's a polyhedron. It means like a many-sided or many-faced, like many faces of a shape is what it breaks down to. We have a couple other vocab terms here. So we're looking at a polyhedron, right? We have faces, what we just talked about. They're the flat surfaces there. So that like light blue side is called a face. The edges are just these pieces here, like the edge, right? That's like the edge of the shape. So it's like kind of where the two faces connect. And then the vertex is like right in the corner. It's like where the edges meet. So wherever you have edges meeting, that's a vertex. And then just so you know, the plural of vertex is vertices. So you don't say two vertexes. You just say two vertices. It's kind of a weird way to say it, but that's what it is. Prisms. A prism's a polyhedron that has two congruent and parallel polygons as bases. So like here, you're going to see the base is here and here, okay? They're congruent, they're the same size, and they're parallel to each other, okay? If you have a rectangular prism like this, we can just say the bases are the top and the bottom, but the top and the bottom aren't always the bases, right? Because if I look at this shape, the bottom of this shape is like one of these rectangles down here, but there's not a parallel one up top here. They would not be parallel. So the faces for something like this would be the side that's not a rectangle. So on this pentagonal prism, the pentagons are the bases. It's called a pentagonal prism, and it's named by the bases. Here's some other examples, right? Like this tent, right? The bases would be the triangle ends. It wouldn't just be the bottom. A lot of times when we say base, we think the bottom of something because that's how we use it when we speak, right? But the base is this. It's the two congruent parallel sides. Those are the bases. Every other face of a prism is a rectangle. Okay. So down here, these numbers got a little mixed up here, just a little bit, but we name prisms and pyramids by their bases. So if the base is a triangle, it's a triangular prism, or a triangular pyramid. If it's a rectangular base, like a quadrilateral, we can say it's a rectangular prism. If it's a pentagon, it's a pentagonal prism. So that kind of goes with all those words there. Down here, we're going to practice classifying these figures. This first one, we're going to say, for what solid it is, we'll say rectangular prism. Right, this thing. It's a prism because it has two bases that are congruent and parallel to each other. Faces, we're going to say how many it has. So I've got a front and a back, a top and a bottom, and a left and a right. So that means I have 6 faces. Vertices are these parts where the edges meet. So I should have 8 of those. So we'll say that's an 8. Edges are going to be these lines, these pink lines, right? So there's 4 there, 4 there, and then 4 more going this way. So that should be 12 edges, right? This one's going to be the exact same thing as this. These are both rectangular prisms, so they'll have the same answers. This one kind of looks more like a cube almost, maybe, but it would have all the same numbers: 6 faces, 8 vertices, 12 edges. You can call it a cube potentially, or you can call it a rectangular prism and always be right. Right? All cubes are also rectangular prisms. That's like the best way to name it because you know that's always going to be right. This one, my base is this. It's a pentagon. It's a prism because I have 2 pentagons that are the same size and they're parallel to each other. So this is a pentagonal prism, right? Faces, So let's think outside of this thing. We've got one in the front, one in the back, and then 5 around the edges. So that should be 7 faces. Vertices, I've got 5 in the front and 5 in the back. So that's 10. Edges, let me erase these things here. Edges would be these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 edges. This has a lot of edges, right? Where all the faces meet. That's what we're looking for. Okay, a pyramid. It's a polyhedron with only one base. All the other faces are triangles that meet at a vertex. So this rectangular pyramid because the base is a rectangle. Triangular pyramid because the base is a triangle, right? Pentagonal pyramid, base is a pentagon. So they're named by their base. The thing you'll notice here is like the faces, I've got 4 faces going around it plus the bottom, so that's 5, right? Over here, triangular pyramid, I have 3 triangular faces around the edges and 1 on the bottom, that's a 4. Pentagonal pyramid, I've got 5 going around and 1 on the bottom, that's a 6. So like a rectangle has 4 sides plus that 1 base. That's how we get 5. A triangle is 3, but I also include the base. So that would be 4. A pentagon is 5, right? But I add the base, so I get to 6. So you'll see that with pyramids all the time. Vertices over here, it's going to be the same. That's going to be 5. Vertices for this one. 1, 2, 3, 4. Same. Pentagonal pyramid. Same thing. So faces and vertices should be the same. The edges, so if I look at those edges here, I've got 1, 2, 3, 4, 5, 6, 7, 8. So we'll say this is an 8. Here we got 1, 2, 3, 4, 5, 6. So this is 6. All right, and then over here, the last one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a 10. Good, okay. Let's keep going here. So we have some other things that are not polyhedrons. We have spheres, cones, cylinders. They're not polyhedrons because polyhedrons have flat faces. All of these things have some sort of curve to them, right? A sphere is just like one big total curve, right? It's got no base. It's just one big curved surface, just like a ball. A cylinder has 2 flat circular bases, so like this and this, right? But then it's just got like one big curved surface that goes around it like a soup can. A cone has a circular base, but it's only got 1. The cylinder has 2. Here, there's a vertex at the top, and there's a big curved surface that kind of wraps around it, sort of like a party hat or a cone, like an orange cone, you know, something like that. So these ones we're classifying: prism, cone, sphere, or cylinder. So this one, megaphone. Now it's not exact, but this is a large circle. This is a smaller circle. We're gonna kind of we're trying to get the overall shape of the thing, right? So the overall shape here is gonna be cone shaped. Even though this technically doesn't go to a point, in general it's a cone shape. And even if you think, like if you think about like an actual traffic cone, right? That looks like this. When you think about that, the top of the cone doesn't actually come to a point, right? It's just like kind of flat on the top and there's like a hole in the top. But we call it a cone because that's like basically the shape that it is, right? This building is called the Pentagon. That's the name of it. So this pentagon is a prism. Specifically, it's a pentagonal prism because you've got a pentagon on, here, let me do this again. You've got a pentagon along the top of the building, okay? And you have a pentagon along the bottom of the building. It creates like a shallow prism. Over here, this one, you could say cone for sure. You can even say, if you wanted to, you can argue that the ice cream is like a sphere. and the cone, ice cream cone, is a cone. I think overall they're trying to get you to say cone, though. That's what they're generally trying to get you to do. This can of soup or vegetables or whatever, that's a cylinder, right? Two circular bases and a curved surface all the way around. Ball's a sphere. Any ball would be a sphere. One big curved surface. And then they're talking about this like stick of butter here, right? So this would be a prism, rectangular prism, because you've got a base on the bottom and a base on the top, and they are parallel to each other, and they're the same size. Okay, a net. A net's a 2D version of a 3D shape. So here's a net of a cube. It's like, kind of think about it like if you took it and like unfolded it, it would look like this, right? This would be the base. This would be the front and the back, the left and the right, and then the other base would go like right here, and you would wrap it up, and that would be the two bases. So I say over here, think of a net like the unfolded version of a 3D shape. It's like you took that shape and just unwrapped it, like if it's made out of cardboard or something. Okay, last thing, we're going to talk about cross sections, okay? A cross section is when you take a shape and you cut it, and you examine the shape that's left by the cut. So it says Melinda's candy bar is in the shape of a triangular prism. She cuts her candy bar parallel to its bottom. So it's like a knife is coming through and slicing it in half like this way. Why that would be cut like that, I don't really know. But I guess you would probably cut it like this normally, like just chop at the end off. But she's cutting it this way for some reason. So the dotted line in the picture represents her cut. So what is the shape of the cross section? So when you do these kind of cross section problems, you want to imagine that you're slicing it with a knife, and then you take this top part and you pick it up and you just like throw it away, and you look at the shape that's created, that's like left there underneath. So if you think about this red shape that I'm outlining here, if you took the top off, right, you sliced it off, and you're like standing straight on top of this prism and you're looking down at it, what shape would this red border be, right? Like if you're looking straight down at this thing, it's a little tricky, but this would be letter C, a rectangle, right? So if you said, a lot of times people think B, because that's kind of, it looks kind of like a diamond-y shape, but you have to remember you want to stand like directly on top of this, and you're like looking down, right, directly at this from the top. You're not looking at it from the side like this. Okay, this letter D would be like if you chopped off like this, you cut it like that, right? And then also remove the top, or you can, maybe you would say like it's just like that, but that's not what we're looking for. We're looking for this piece that's left over. Okay, see you later, guys. Have a good day.